Okay, so now we're just going to be doing question 9, which says in the diagram we have DEFG, which is a cyclic chord with DE parallel to GF, right? And D is produced to R. T is another point on the circle, right? So we have EG, FT, and ET, which are drawn. So we have E4, angle E4, which is equal to 72 degrees. We have angle G1, which is equal to 16 degrees, right? So now, what I need to note is that sometimes, just sometimes, by the way, all the information is indicated in the circle, right? But sometimes it's not. So you need to make sure that you highlight the given information. Anyways, let's continue and solve these problems here. So the question here says that we must determine with reasons the size of the following angles, right? So we're gonna do 9.1.1. we get asked to determine DGF. So what I would advise you to do, you must have your highlighter so that you highlight the needed angle, right? So it makes it easier for you to be able to find a specific angle, right? As long as it won't be complicate things for you, right, in the exam, right? Or you can have, actually you are given a piece of paper where you can actually do that. So please do that and highlight. So here we're just going to highlight this DGF, right? So we're just going to highlight DGF, right? So we're just going to highlight the needed angle so that we know or we have a direction on how to find it. And remember that these are parallel, right? So I'm just going to indicate with this color here. So to find this angle here, what we have is this. I'm just going to, I know I'm highlighting a lot of things now, but what we have is this. I'm just going to use a different color. What we have is the cyclic chord of DEFG. That's one thing that's going to help us find this angle here. Right, so the DEFG is this one. I'm going to highlight using this color here, right? So obviously including this one that is red, which I won't highlight. So now we're having a cyclic chord and we're having an exterior angle of 72 degrees, which is this one here, right? And this angle here is equal to the opposite interior angle. Remember that? So that's exactly how we're going to find the angle. So we are done basically. So what you're going to do is you're going to say DGF, sorry. So it's DGF is equal to 72 degrees, as I said. So it's 72 degrees here. Reason being is the exterior angle of a cyclic chord is equals to the opposite interior angles, right? So that's how we found this angle here. So now let's go to 9.1.2, which we are asked to find angle T. So let me just remove these colors here because now they're gonna distract me to solving other problems. So we want angle T, which is this one here, right? For us to find that, if you look clearly, there's this here, goes like this. I'm sure you're familiar with this shape that looks something like this, right? It's the one of angles on same segment, right? Meaning that this angle here is equal to this angle here, and this angle here is equal to this angle here, right? So for us to find angle T, we need to find angle G first, right? G2, by the way. So how do we find G2? Let me remove this quickly. To find G2, remember that we already found this entire angle to be 72 degrees. So it's easier now to find G2 because it's part of that angle. So you want to say the entire angle of, which is the one that we calculated previously, DGF is equal to a combination of G1 plus G2, right? And you already know the entire angle, which is 72 degrees, equals to G1 is 16 degrees. So now to find G2, we're just going to transpose this to the other side. You have G2 being equal to 72 degrees minus 16 degrees. So G2 is equals to just use a calculator. I used mine, which is 56 degrees, so that is G2. So now it's easier for us to find T, right, because they are of the same segment, right? What do I mean by that? This chord here, so these triangles share the same chord. So this chord here subtends an angle here, and it also subtends an angle here. Hope that makes sense. So making these angles equal, so hence we use the angles on the same segment. So now now that you know that, so G2 is equals to F is equals to 56 degrees, right? So you can just write your reason next to that, which we know the reason is angles on same segment, right? So yeah, we found T. So now let's go down to finding GEF, which is the next question, 9.1.3, right? So we're asked to find GEF, right? What is GEF? Let's look. G is this one, E is this one, F is this one. So oops, so we're having something like this, and we're asked to find this angle here. So for us to find this angle here, we already know G2, right? We already know this angle here, which is equals to 56 degrees, right? We don't know F1, right? We don't know F1, but we can find F1. We can find F1. So basically, for us to find this angle here, we need to first find F1, right? So let me do that. First find F1. So how can you find F1? I want you to look at this. We are having this line here, this long line here like this. We are told it's parallel to this line here, right? So they are parallel. So meaning, and if you take a look, I'm just going to indicate another color. This is actually Z. This is Z going downwards, right? So if you have Z, obviously it's in the parallel lines. So it means now that this angle here is equals to this angle here. What's the reason? Just say it loud. Obviously I can't hear you. It's alternate angles equal, right? So meaning here it's also 72 degrees. So simply say F1, angle F1 is equals to 72 degrees. Reason is alternate angles equal. So how do you find those alternate angles equal? By using the parallel lines of DE being parallel to GF, right? So now we found our F1. Now we'll be able to find what's required, GEF, right? Angle GEF. So to find angle GEF, which is what I did earlier, is by drawing this triangle, because it's within this triangle. Oops, I know I'm just not drawing it properly, but you can see just by drawing this triangle here, want this angle here, we already know this, which is 72 degrees. We already know this, which is 56 degrees. So we just want this angle here. So we're just gonna say GEF plus F, which is this one here, plus G2 is equals to 180 degrees, right? So it's G2, and then GEF is equals to 180 degrees minus F minus G2, right? So meaning 180 degrees minus our F is 72 degrees, our G2 is 56 degrees. Please punch your calculator and you'll get 52 degrees. So that is the answer. Obviously you have to write the reason. What did you do to find that angle? The sum of interior angles of a triangle, right? Okay, now so let's try out this problem here. You can pause the video and attempt finding these angles here at the bottom, right? Finding all these angles and just see if you are now understanding on how to solve or how to find angles of circles. Okay, let's begin. So the information that we're given here is that O is the center, right, of the circle, and MNPR is a cyclic chord, right? SN is a diameter, and chord MS, then we have a radius of OR. Given the angle of M2, which is equal to 64 degrees, right? So now, the first question we're asked to determine the angle of P, which is this one here. And we were told, remember, we're told that this is a cyclic chord. So I'm just going to indicate it. This was a cyclic chord, right? So since it is a cyclic chord, right, this angle here is added with this angle here to give you 180 degrees, right? Opposite interior angles of a cyclic chord are supplementary. That's what we need to know. So that's what's going to help us find angle P. So we're going to say angle P plus angle M2 is equals to 180 degrees. And then I'm going to indicate the reason, saying opposite interior angles of a cyclic chord are supplementary, right? So they add up to 180 degrees. So to find angle P, we're going to transpose M2 to the other side. So we have angle P is equals to 180 degrees minus angle M2. So what is angle M2? Is 64 degrees. So 180 degrees minus 64 degrees. Please punch through your calculator. You're gonna get 116 degrees, right? So that is the angle of P. Now let's try out this one here, which is 8.1.2. We must find angle M1, right? So let me just remove this. So we want to find angle M1, which if you take a look at the diagram, which I'm going to remove this color here. So if you take a look, want to find this angle here, right? M1. We already know M2. Where am I going? Remember that we were told that this is a diameter. And if you remember some of the definitions in the theorems you did in grade 11, is that if this is a diameter, which obviously this line on its own, if I were to say what's the angle, it's going to be 180 degrees, right? So this angle here is 180 degrees. That means this angle here is going to be 90 degrees. So I'm just going to indicate it with like this. So this is going to be 90 degrees. What's the reason for that? Angles on a semicircle, right? So angle M1 and M2 will give you 90 degrees, right? So we're just going to say, we're going to do this. We're going to say angle M1 plus angle M2 are 90 degrees. So the reason for that is angles on semicircle, right? And we already know M2, so we want to find M1. So we're going to say angle M1 is equals to 90 degrees minus angle M2, which we know angle M2 being 64 degrees. So 90 minus 64 gives us 26 degrees. So this is your angle M1, right? So we are done with this question here. So now let's go to the last question of finding angles, which says we must find angle O1, right? Angle O1 is this angle here, right? Remember we were told that this is a radius, right? Angle OR is a radius, right? So let me just do this. So what I need to look at is this shape here. Let me remove this. So I want you guys to look at this shape. So it goes like this, goes like that, and it also goes like this and like that. So if you just take a look at this shape, which theorem is this one? Just take a guess which theorem is this one. But I'll tell you. Remember the theorem where we had this and that, you know, and this at the top was moving either that direction or that direction. So you'd have the same thing, right? but now it moved to this point here. It was here, now it's here, right? Which is the same thing, right? So this is the center equals to twice circumference. Center twice circumference. So this is theorem 3, if you got it. This is theorem 3. So the same thing happens here. So this angle at the center is twice at the circumference. You know, people always confuse this with this theorem here. I don't know why, but what I need you to note is this: these two are different. Why am I saying they're different? This one, all the corners are at the circumference. All the corners are at the circumference. Hence, you're going to say it's angles on the same segment. Angles on the same segment, because all the corners are at the circumference. But this one, all the corners are not at the circumference. It's only this at the circumference and this, but this one is not at the circumference. So you can't use angles on the same segment for that. I hope that helped. Anyways, let's continue. So now we know this is theorem 3, right? So we're gonna say because we want O1, so angle O1 is equal to twice angle M1. Hope that makes sense now. This angle here is twice this angle here, right? Then you're gonna write your reason, obviously. Here you're just gonna say angle at center is equal to twice at circumference, right? So what is M1? We already know M1, right? So angle MO1 is equal to twice M1. We found it. Previous question took be 26 degrees, so it's equals to 52 degrees. So this is your O1, right? So yeah, we're done with these types of problems. Let's continue doing another one, so that you get used to finding angles of circles, right? So now let's try out this problem here. If you haven't subscribed, please do subscribe to the channel so that you have notifications on future videos. Anyways, let's solve this problem here. But you can attempt it if you want. You can pause the video and attempt it by finding the questions below, right? Anyways, in the diagram, PQRS is a cyclic chord, so that's the information you're given. PS is produced to W, TR and TS are tangents, right, to the circle at R and S. T is equals to 78 degrees, Q is equals to 93 degrees, right? Sometimes the information is indicated in the circle, sometimes it's not, it's in the statement, so please take note of that. Anyways, 9.1, we are asked to give a reason why ST is equals to TR, why this line here is equals to, actually let me draw it nicely, why this tangent is equals to this tangent, right? If you remember clearly, there's a theorem that I did which has a circle and tangents like this, and this was P, and this is the center, and then there were, you know, just lines like this which are radius, and then there was this line here. So if you remember this theorem, we're asked, let me say this is B, this is A. We're asked to prove that this tangent is equal to this tangent, right? So we did congruency by proving that. So now you know that these tangents are equal. But what makes you think that these tangents are equal, right? It's because they share the same point. They share this point here, right? And they go all the way to the circumference of the circle. So now you know just by that theorem that we did. Anyways, let me remove this. So that's your answer for 9.1. So you're just gonna say ST is equals to TR. Reason for that is tangents from same point, right? So that's how we find that reason. Anyways, 9.2 says that calculate with reasons the sizes of the following. So 9.2.1, we are asked to find the size of S2, right? S2 is this angle here, and since we just proved in the previous question that this tangent here is equal to this tangent here, so which means if you think about it, it's an isosceles triangle, meaning the base angles are equal. So if this is x, this is also x, right? And we're asked to find S2, which is part of those angles, right? So how do you do that? We're going to say angle S2 plus angle R2, right? Plus this angle here, which we are given angle T, is equals to 180 degrees, right? So that's just the sum of interior angles of a triangle, right? And we already know that S2 and R2 are equal. So it's x and x, right? So it's x, and then plus our angle T is 78 degrees equals to 180 degrees. So you know 2x equals to 180 degrees minus 78 degrees. Divide by 2 both sides, and then your x is equals to 51 degrees. So therefore your S2, your angle S2 is equals to 51 degrees, right? So that is the answer for S2. Now let's do 9.2.2, right? Which we're asked to find angle S3 in 9.2.2, right? So how do you find that angle? We want to find this angle here. Right, we already know this angle here, right? And we have this angle here, which is 93 degrees. If you remember, this is a cyclic quad. This is a cyclic quad. We were told in the statement this is a cyclic quad. So if this is a cyclic quad and we have this angle of 93, it means now that this exterior angle is equal to the opposite interior angle, right? So the exterior angle is S2 plus S3. So that's the exterior angle, being equals to what? Being equals to Q, right? So it's equals to Q. So the reason is exterior, oops, what am I doing? So it's exterior angle of a cyclic quad, exterior angle of a cyclic quad. So what is S2? We found S2 to be 51 degrees in the previous question. Plus, what is S3? We don't know. It's what we are looking for. And Q, it's 93 degrees. So transpose 51 degrees to the other side. We have angle S3 being equals to 93 degrees minus 51 degrees, right? Punch your calculator, you're going to get 42 degrees. So that is your S3. Let's try out another problem. Okay, guys. So now in this problem here, we are given that O is the center of the circle, so that's the first statement, and that KOM bisects LN, right? And then M and O is equals to 26 degrees. K and P are points on the circle with NKP being equals to 32 degrees, right? So as I said, as I keep on saying, is that some of the information may be indicated in the circle and some in the statement, or all information is actually in the circle. So you don't have to always just look at the circle and not pay attention to the statement, because some information might be missing in the circle but might be in the statement. So take note of that. Anyways, let's solve the problems here. So it's 8.1.1. We are asked to find the sizes of the following with reasons. So we want O2. We want to find this angle here. So to find that angle, I want you to look at this here. I think I've been doing the same problem in this very same video. So this problem keeps appearing. So this one here, where you have this angle here being equal to twice this angle here, right? It's twice this angle here. So that is theorem 3, right? If you remember clearly. So what you're going to do is this. So let me remove this. So what you're going to do is you're going to say angle O2 is equal to twice K1, right? It's equal to twice angle K1. So we already know angle K1, which is 32 degrees. So meaning that O2 is equal to 64 degrees, right? So you can specify the reason next and say angle at center is equals to twice its circumference, right? So that is O2. Now let's do O1, this one here. So before I do that, let me erase here. So to find O1, which is this angle here. It's quite tricky to find it. Why? Because we can't really find angles that are relating to it, or in this triangle here. If I were to look at this triangle here, I only have this angle and not this and not this, so we can't use that. So the only way that I can see working for this one here is we are looking for this one, right? And we now found this in the previous question. We don't know this angle here, right? So let's first find O3. How? Because this is theorem, I don't know if you can see, this is theorem 1, this one here, and then it goes straight to the center of the circle, and we are told that these are equal, right? So if they're equal, then this is 90 degrees, right? So it's 90 degrees. So we're just going to look at this triangle here, right? Because we already know 90 degrees, already know 26 degrees. We just want to find O3, right? I hope making sense now. So let's first find O3 before we find O1, right? So how do we find O3? As I said, we're going to use this triangle here, where this is 90. So M2 is equals to 90 degrees. Maybe you can specify the reason and say NM is equals to ML, right? And then what we're going to do is we're just going to add. So O3 plus M2 plus angle N is equals to 180 degrees, right? So reason for that is sum of interior angles of a triangle, right? So O3 plus what's M2, it's 90 degrees, what's N, it's 26 degrees, equals to 180 degrees. And then you transpose all the other angles to the other side, and then we have 180 degrees minus 26 degrees minus 90 degrees. So please punch this in your calculator, and I'm getting 64 degrees for this one, right? So that is O3, angle O3 is 64 degrees. So I'm just going to indicate that in here. So now I have 64 degrees, and O2, remember, it was also 64 degrees. So now I want O1, which now it becomes simpler, right? So let me erase this. So to find O1, this is a straight line, right? Since it's 90 degrees here, which means this is going to be a straight line because it passes through the center of the circle. So making this being 180 degrees, right? Because the straight line, right? So meaning what you're going to say is you're going to say angle O1 plus angle O2 plus angle O3 is equals to 180 degrees. Reason, you can say straight line. Straight line. So what is O1? O1 plus what's O2? 64 degrees. O3 is 64 degrees equals to 180 degrees. Then you transpose all the other angles to the other side. You have angle O1 is equals to 180 degrees minus 64 degrees minus 64 degrees, right? And the answer that I got is 52 degrees. So that is, excuse me, that is O1, right? So we are done finding this angle here. And then now we have the last question of this problem here. Just gonna erase these. So the last question says that we should prove by giving reasons that Kn bisects OKP. So this question likes to appear in exams. It's really important that you know it. So when they talk of a line bisecting two lines, basically, or an angle, it means you have to prove that these two angles are equal. So what does that mean? We are told that this line here, right, so I'm just going to indicate it in red, bisects this angle here that is between these purple lines. So it bisects this. So how do we prove that it actually does bisect? Is, you see here it's 32 degrees, which means we have to also find 32 degrees here, Once we find 32 degrees here, then we know that actually this line of Kn bisects the angle of K1 plus K2, right? Or let me just say this line here and this line here. So that's how we identify if a line bisects an angle. It actually splits. It splits one angle into two equal parts, if maybe I can put it that way. If, let's say, for example, I had 64 degrees, right? This was 64 degrees, right? And then I bisect it, meaning I'm equaling these this angle into two equal parts, meaning this side is going to be 32 degrees and this side is going to be 32 degrees. So that's what Kn did. So what you need to prove is that this angle here is actually 32 degrees. Then you have confirmed that it actually did bisect. I hope now that makes sense. So let's find this 32 degrees, right? So what we're going to do is this. Looking at this triangle here in red, I'm just going to use it to solve this. So looking at this triangle here, you can see that this side here is equal to this side here. Reason, it's equal radii. So you can just state that in your statement, KO, not the KO who sings, but yeah, KO is equals to ON, right? So KO is equals to ON. Reason for that, equal radii or radii, whatever you pronounce it. So if they're equal, and this is an isosceles triangle then, so it means that these base angles are equal. So you can say x here and also x there, right? So we already know this O1 plus O2, right? We found O1, we found O2. So just combined, you can say angle O1 plus angle O2 is equals to O, the entire O, right? But the O of which triangle? Of triangle KON, just to be specific, right? So what is that O? It's equals to we know that it's 64 degrees plus 52 degrees, right? Which if I combine the two, I got 116 degrees, right? So what you're going to do is this. In your triangle, you're going to say angle K2, which is what we are looking for, plus angle N plus angle O is equals to 180 degrees. Reason is sum of interior angles of a triangle. So what is K2? It's x. What is N? It's x. Plus this, which is 116, equals to 180 degrees. So it's 2x is equals to 180 degrees minus 116. Divide by 2 both sides. X is equals to 32 degrees. So I've just found the 32 that we've been looking for. So now we know that this angle here is 32 degrees, right? So we found x to be equals to 32 degrees, meaning that K2 is equals to 32 degrees, right? So therefore you can conclude, you say therefore Kn bisects OKP, right? So we have concluded with this problem here. So now I'm just going to be giving you problems which are more similar to these. Please try them out. So please do try out these problems here. As you can see, you're given this diagram with angles and you're asked to find other angles, right? Please try it out. Let me know the angles that you found for 8.1.1, 8.1.2, 8.1.3, and 8.1.4. If you want to know which paper I used here, it's 2019 November. I will leave the link in the description of this video. Yeah, so just let me know which angles you found for this problem here. Thank you so much for watching. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.